Hello everyone, I come from Beijing Institute of Technology. Here we propose a paradigm called inverse augmented reality, which is the inverse process of the traditional human-centered augmented reality. In this paradigm, the virtual agent is the main element of the whole system. We assume a virtual agent in the virtual world. We assume a virtual agent in the virtual world has fully augmented intelligence so that it can observe the virtual world and the physical world as humans can do. Thank you.
Good afternoon. We conducted a controlled experiment about visual fatigue on primary students after exposure of two kinds of displays, HMD and a tablet computer. There were three phases of our experiment, and it's a within subject design. So our preliminary result indicate that HMD has a tendency to bring higher visual fatigue after exposure of 1 hour use. Poster 1026, thank you.
Lily Wang from Beihang University. What happens if the people have a super ability to view the scene with zoom in and zoom out interactively? We propose a method to enhance VR and AR scene exploration, allow user to adapt the field of the view. User can zoom in to get a great detail of the scene. User can zoom out to get the whole image of the scene. For more details, please come to our poster. Thanks.
Okay, hello everyone. I'm Mathieu Fradet from Technicolor. This work is the work of Glenn, master student. So it's about diminished reality running in real time on mobile devices, on consumer mobile devices. So if you have ever wondered how to make real objects invisible, or in case you have ever wondered or dreamed to be invisible yourself, come to check actually our demo, because I will present the demo in the same time in the demo room. Thank you so much.
Hello, Mario Lorenz, Technical University of Chemnitz. No, that's not me. Oh, they switched? Okay.
Okay, so I go first. Okay, hi. My name is Jan-Philipp Freiwald from the University of Hamburg, Germany, and these are actually my slides. Very nice. So, video see-through AR has some benefits over optical see-through. For example, the ability to render fully opaque virtual objects, but that comes at a hefty price, as users frequently suffer from cyber sickness symptoms, mainly stemming from the latency of the video cameras. So, if you would like to learn why the solution to that problem is to actually add even more latency to the setup, then please come join me at my poster with our little cyber sick friend here on it. Thanks.
So, hi, it's me again. And in our EU project Precom, we are developing AR applications to support maintenance technicians. And we have 3 demonstrator partners. One is producing wind power plant hubs. One is producing precision rotational gears. And here we see a paper tissue producer. And we gather the technical user environmental and regulative requirements. For example, you have very high humidity there, or they have to wear protection gears. And we show the implications on the AR systems that origin from all these requirements. Thank you.
So, hello, I'm Pascal Knirium from LMU Munich. I'm really happy to present the work I did with the co-authors Francisco Kiss and Albrecht Schmidt at our university. And what we did, we built a system which actually amplifies human vision and let physics students watch at thermal experiments and see actually the thermal flux. And since we are also presenting a demo, I really recommend you not going to the poster because no one is there. Go to the demo booth on the other side of the conference and see me there if you want to try this, because it's way more fun trying it than just watching it. See you there. Thank you.
Hi, I'm Chan Park from E3. Most working-in-place interfaces determine the locomotion direction according to the user's gaze direction. However, we may turn our heads around to see the surrounding environment in natural working. Our working-in-place system allows users to work in the locomotion direction while they turn heads around to see the virtual world using a low-cost IMU worn on the waist.
Hello, I'm Stefanie Zollmann. I'm from the University of Otago, and I'm going to present the work of my student Patrick, who was working on indirect AR browsers for geographic data. And the main idea is that usually if we use traditional AR browsers, we run into several problems like registration problems, but also information overflow. So what we're trying to do in our project was to combine pre-captured 360-degree footage to provide an indirect AR augmented reality browser. And if you want to know more, just visit my poster. Thanks.
Hello everyone, my name is Li Zhang from MPU China. We hold the view that every physical object can be personified to have and express emotions using augmented reality. So relationships between objects can be presented using emojis. In a manual task, we found that the emotional queue can help to decrease time, but increase more errors. Thanks.
Hi everyone. Oh, that's loud. My name is Uwe Grünefeld. I'm from the University of Oldenburg, and I'm talking about how to guide smombies. So smombies, that's a word that appeared in 2014, 2015 in Germany, which means people that are actively on their phone, and they are basically like zombies because they don't realize anything anymore. And what we looked in detail here is we developed a low-cost glasses that aim to augment peripheral vision with light stimuli, and we did that in 2 iterations. And if you want to see that and which light stimuli works best, please see our poster. Thank you.
My name is Christy, and I'm from the University of Hong Kong, and my experiment is having 4 conditions: 2 speed and 2 devices include cave and head mount devices. And it is the first environment is on a street and with some surroundings, and it is the participants are required to stand still, and the environment will move in a forward direction. And it found that the higher the navigation speed, the higher degree of cyber sickness, and also the participant will experience less discomfort if they experience cave first. Thank you.
Hi, my name is Steffen from the University of Würzburg, Steffen Hesler. My question is, did Alexa really turn on the heater? So if you give a task to an intelligent virtual agent, how do you control if it's executed correctly, unless then checking with a smart home app or anything like this? So what we did is we gave her a body which is augmented in your real environment and checked how this will affect the trust in the execution of task. So if you're interested in an embodied augmented Alexa, please come to my poster.
Hello, this is Patrick from TUM. We looked a bit further ahead into the future of autonomous driving and when we have these things even in the urban environments. And we made a prototype for a windshield display interface that uses augmentations to convey to the driver what the car can actually perceive and to give him more comprehension about driving maneuvers or decisions that may be surprising. And if you want to see the first results we did in our simulator, please come to our poster. Thank you.
Hello, I'm Pallavi from NTU Singapore. Question: how do you click an object in VR using just your eye gaze? More importantly, how does the system know that you are looking at an object that you want to select, as opposed to just looking at them only? This is the Midas touch problem. The solution? My dual gaze method. This method has been proved to be more accurate and faster than other traditional solutions to this problem in VR. How did I do that? Come find out in my poster. Thank you.
Hi, I'm Andrew from University College Dublin. We collaborated with DAQRI to conduct a user study comparing the performance of an AR HMD to a non-AR tablet manual on a multi-step maintenance procedure. We found the main finding was that on one task step, AR improved performance by 68% relative to the instruction manual. That task step was a precise measurement task, and that compares to only a 33% average improvement across all steps. So AR benefits performance in certain task steps more than others.
Hello, I'm Johnny Collins from the University of Otago. So this first work is based on a study proposal from the early 1970s, which looked at using virtual environments to present interactive, abstract mathematical constructs like a hypercube to study constructivist and experiential learning theories. To our knowledge, the study was never conducted, and so this work looks at an initial implementation of the experiment with a system based on the original, as well as an extended modern, fully immersive system. And in this next work, so virtual reality has been used for the study of psychological phenomenon related to body perception. And we wondered if the same effect could be transferred to augmented reality devices. And so we implemented a system using the HoloLens device and a Kinect to present the user with a body image, which we can manipulate by increasing and decreasing their body size, and then evaluate that for body perception and embodiment, which is required for such an effect. Thank you.
I'm going to stand over here for a change. Click. Do I do the clicking? You do the clicking. Hi, I'm Rado from the TU Delft. A significant number of patients with congenital heart disease have inadequate knowledge about the condition, and an informed patient is a good patient in that they adhere to their medication and self-care and recovery. Previous work has shown the value of using augmented reality in a medical context and portraying virtual objects, organs within the body. But the value of this ownership and therefore the relevance is challenged by the proximity, the imposed size, and the limited field of view of head-mounted augmented. That's a lot quicker than I thought. Come see me at the booth.
Hello everyone, I'm Kohei Kanamori from Osaka University. We propose walking support system in real space using social force model when wearing immersive HMD. Social force model is a model assuming that virtual forces are working to the user who walks to the destination while avoiding obstacles. We can find optimal route to the destination and so as not to hit other pedestrians and obstacles by simulating these virtual forces to working to the user. Thank you for listening.
Hi everyone, my name is Kelvin and I'm from Rakuten, which is an e-commerce company headquartered in Japan. And recently we've partnered with FC Barcelona, and to show everyone about our partnership, we've created a mixed reality experience on top of an exhibition in a cafe, which we were showing FC Barcelona historic jerseys. And this was exhibited in Japan. And so come to our poster and our demo. We are located in a demo room and find out all about this interactive mixed reality experience. Thank you.
Good afternoon, everybody. My name is Anne Mcnamara. I'm from the Department of Visualization at Texas A&M University. So we are using eye tracking to improve information retrieval in virtual reality. Rather than display all the available information and overwhelm the user or occlude objects in the virtual environment, we're just revealing the information where the user is looking. So basically the user attention is triggering the information retrieval events. And if you'd like to, we actually did an experiment which showed our method was faster and more accurate in terms of performance when compared to existing methods. And if you'd like to know more, please come visit me at my poster. I'm down on the far right. Thank you.
The name is Jonathan Hart. I'm a PhD student at the University of South Australia. Basically, I work on sharing, augmenting emotion in collaborative mixed reality. So basically what we do is we take the webcam video and we use some software to map the webcam video, detect the expressions, then put them on the avatar. But the big difference is that we are going to augment the expressions. So you can appear a little bit happier, or you can appear happy when you're sad, or you can have the expression of a lion or a monster, and yeah, just come check me out. I'm going to be at the demo because I got a demo and a poster, so yeah, the demo is basically quite similar, so just see me over there. Thank you.
Hi, my name is Daniel from the University of Würzburg, and in this project we investigated the augmentation of human gaze behavior and avatar-mediated social interactions, and for that we compared 3 transmission types: natural gaze, which was tracked by 2 eye trackers; hybrid gaze, which was augmenting natural gaze by a social gaze model; synthetic gaze, in which we augmented random gaze by a social gaze model; and random gaze, which was basically just a computed random fixation and distribution and duration. And our major findings were a linear trend, where natural gaze performed best and random gaze performed worse. For more questions, see us at the poster.
Hello, I'm again, and this time we proposed a typing system. This system consists of a depth camera, an HMD, a tracking device, a table with a black table mat, and a physical keyboard covered by infrared absorption material. And combined with RGB and depth image to segment the hand area, then the hand map and the virtual environment can be fused to a mixed reality scene. The entry rate is over 23 watts per minute, and the ratio of virtual reality to real world is up to 78. Thank you.
Hello everybody, my name is Giorgio Balestin from University of Genoa. In our study, we analyzed the compression of perceived distances that can be caused by the different optical characteristics of head-mounted displays. So we had 2 task groups that had to perform a precision homing task while wearing either an optical see-through device or a monocular video see-through device. And then we compared the results. Moreover, we analyzed how the presence of an internal feedback can help to achieve a more effective interaction by reducing this distance misperception. So if you're interested, come by and check it out. Thank you.
Hello, I'm Thibaut Michel from INRIA in France. In a perfect world, if a user is aiming a tree with a AR device, the virtual information, this is a tree, is well placed on the screen. But now, if you consider an error due to a bad position estimation, for example, GPS, this error will appear on the screen. And in addition, if you consider also an error due to a bad estimation, for example, fusion from AMU, this error will grow. So what we propose is a method to evaluate this error on the screen, given an attitude estimation and a position estimation error.
Yeah, hi everyone, I'm Doris Aschenbrenner from University of Delft. We conduct a user study with remote repair. There is a side barrier between the remote expert, who is not really remote, and technical apprentices who do kind of complicated repair task as a switch cabinet of an industrial robot. So we had apprentices, technical apprentices in 6 groups comparing different spatial augmented reality, HMD and tablet tracking, handheld devices. And we were able to find some evidence that the augmented reality is better than the and also especially a projector-based spatial augmented reality.
Hello, I'm Paul Bala. I'll be presenting a study comparing,
No.
Okay, a study comparing and combining visual optimization techniques in 360 video to reduce visually induced motion sickness. The two techniques are independent visual background and a restricted field of view, and both use a dense optical flow algorithm as input. So learn about it in our poster. Thank you.